All right, guys, we're going to go over the review, majority of it, but you do need to do some practice on your own. I'll try to set you up to get it completed. I've highlighted some key information and add some additional notes to make sure you know what to study and look for on a problem for your district assembly 6 weeks test. All right, so proving quadrilaterals on the coordinate plane. Key to this is use your slopes and distance formula / Pythagorean theorem. Now I'm going to show you how you can use your slope to help you do some problem solving and make it a whole lot easier or faster to get through the problem. So I think some of you might have a typo, so check that your D is 4, 1. But graph your points, okay? So just kind of recap. Our first quadrant, our first order pair is our X. Our second is our Y. Our X is the horizontal line. And our Y is the vertical line right here. We're going to use that in the second part here. So if I'm going 0, 4, I'm not moving on the yellow, my horizontal line. I'm just going up 4, and there's that point. So for B, 3, 8, that means 3 on the yellow, and then up 8. And that would be our point B. Go ahead and put your letter as well. Keep track of your points. Then we have 7, 5. So 7 on the yellow, and then up the elevator to 5. So that's right there. And that's our C. And then D should be 4, 1. So here we go. Here is our D. So we connect our points in order. Order matters. And I know mine's a little off here, but then we're going to make a prediction, okay? Most of us are going to predict square, and some of us might say rhombus. So we're going to write in here square rhombus. Now, we're going to always, once you get them graphic, always start off with using your slope. So let's go ahead and find the slope for each side. So that's our rise over run. So if I wanted to see the slope of AB, I would go up. That's a rise of 1, 2, 3, 4. Okay, or you can count it like 1, 2, 3, 4. Okay, don't count the point that you're on, count from when you're leaving. And then 1, 2, 3. Okay, so our slope here is 4 over 3. And then if I was going to, and I'm just going to erase what I just did so I can just show doing it with B to C, okay? So if I'm going my slope from B to C, from B to C, if I start at B, now I'm going down 1, 2, 3. So down would be negative. And then to the right, 1, 2, 3, 4. So we got negative 3 over 4, right? It's positive. All right, now we're going to C to D. If I wanted to, I can count again. That would be down 1, 2, 3, 4. Down 4. And then to the left, that's negative 2, so that's 3. This actually comes out to positive 4/3, okay? So this is really just positive 4/3. A negative over a negative is positive. And then we're going to do DA. D is going up 1, 2, 3. And then to the left 4. So that would be 3 over negative 4. All right, so there's all our slopes. And we really don't need, I was just showing it to you, but I'm just going to clean this up so we can see the actual slope for each one. So this one was 4/3. All right, so after our slopes, we're going to find the lengths of each side and leave as a square root. Or if it can be simplified into a perfect square, write the perfect square answer. So I'm going to start off with from A to B, okay? If I look at AB, inside my radical, I'm just using my numbers. My rise, which was my 4, so parentheses 4 squared, plus my run, parentheses 3 squared. And then we're going to work them out, order of operations, PEMDAS, exponents first. So we're going to have, underneath our radical, a 16 plus a 9. Continue our order of operations. We have 25. And the square root of 25 is 5. So AB is 5. So we have AB, and I'm going to go ahead and label that on my graph. AB is 5. The length from A to B is 5. So if I was going now to BC, okay. Oh, don't do this on me. Yep, it did. Hold on just a second. It froze. Okay, so if I'm going to do, got it back working. Sorry. If I'm going to do from B to C, that's what I'm going to do next, okay? I'm going to find the length. I'm going to use my rise over run, because that's to me it's faster. BC is, now we have negative 3 parentheses squared plus 4 parentheses squared. You're going to see something if you haven't seen it already. You should know anytime we square a negative, it always becomes a positive. So this is 9 plus 16 again. Isn't that what we had here? So we should know that each of our links, because we're using the same number, is 5. Okay? So we have a 5 on each side. I don't know if you can see that, but I went and put that on there, which I want to show tick marks to show that they're congruent. So I know we have 4 congruent sides. Well, square still works, rhombus still works, but a square is different than a rhombus, okay? A square is a rhombus, but a rhombus is not a square. So the next thing I have up here is you need to look at opposite sides parallel, so we're looking for same slope, okay? So that's important. We're looking for opposite sides parallel, we're looking for same slope, and we're looking for consecutive sides perpendicular. That's the upside down T. So opposite reciprocal slopes. A flip change. That's what I mean. We're going to flip the number and change the sign. So if I look here, right there, I'm just going to take this off. Delete that one and that one and that one. All right, so if I look at my first ratio right here, we have 4/3, and then we have a negative, these two, sorry, negative 3/4. So 4/3 times a negative 3/4 would give me a -1, and I can see that I flipped the numbers and changed the sign. They are opposite reciprocal, so that proves it's perpendicular, which means now we have right angles. So there's a right angle right there. If I go to the same thing, negative 3/4 to 4/3, so now I'm proving that I have 4 right angles because I have consecutive sides that are perpendicular. So the key to this, look for parallel, same slope, look for perpendicular. So evidence to my prediction, well, this is actually a square. The answer here was the square. And the reason why it's a square is because we have 4 right angles, okay, which we proved with the perpendicular because of the opposite reciprocal slopes. And we have 4 congruent sides, okay, which we did with the radical, with the distance formula. Okay, so that takes care of our square. So the key to this is making sure you graph them and you look at your slopes and your distances. So on this next one, we gave you the graph our points. We have 1, 4. There's our A. 5, 4. There is our B. 6, 1. There's our C. And 1, 1. There's our D. And if I connect, and I didn't go in order, but there, A to B to C to D. Now look at this. My prediction is a trapezoid. And for it to be a trapezoid, you have only one pair of opposite sides. Sorry. Parallel. Well, which pair do you think are parallel? Bingo. If you say AB is parallel to DC, that's easy to see because they're both horizontal. And all horizontal lines are parallel, okay? So we're kind of done with that one. Now, I think there's, check to make sure. I think the typo in here is that this 2 on S should be a -2. Okay, so check, make sure you have a -2. So let's go ahead and graph this one. We have -4, +2. We have 2, +6. I'm sorry, that was G. This is my R. And then we have 4, 2. That's my H. And -2, -2. There's my S. So we're going to connect them. G, R, H, S. And come back to G. And we're going to check. Now, looking at it, some might say rectangle. Maybe my graph is just a little off. Now, or we could say parallelogram. Now, so the key to this is looking at the slopes. So we want to look, this lowercase m is our symbol for slope. We want to look at the slope from G to R. So if I can physically count, I'm going up 1, 2, 3, 4. 1, 2, 3, 4. and then I'm going to the right 1, 2, 3, 4, 5, 6. So this was a slope of 4, 6. Okay, so I'm just gonna kind of go to our original. Now we want to look at the slope of R H. So slope from R to H. Here I'm going down 1, 2, 3, 4, and then to the right. So down is negative, to the right 2. Then I want to look at the slope of HS, and that is down 4, and then to the left, negative and a negative. So down 4, to the left, that ends up becoming positive. Uh-oh, we're starting to see a pattern here. And then the slope of GS. And that is up 4, and then to the left 2. So I can see right now we have opposite sides parallel, because we have those two and these two. So we at least have a parallelogram. So there's my arrows to show that. And then I want to look at, do I have perpendicular? So if it's a right angle, if it's a rectangle, it has to have perpendicular. So let's look at consecutive. Let's look at GR and then RH. GR was the 4, 6. Yeah, which can reduce to 2/3. Okay. And then RH was a negative 4/2, which can reduce to 2/1. Well, if I look at these are not opposite reciprocals. So it's not perpendicular. So it only is a parallelogram. Okay? So that takes care of that. Now, let's look here. These are the test-like questions. Of the 4, I would really focus on 3 and 5, okay? And so you write, it's easier if you have graph paper, so there it is right there. And we are going to pause the video to get this graphing done. So once you try to do that,